Okay, guys, let's get started. Thank you, everyone, for coming today. And my name is Hovhannes. I'm working with Questrade. Questrade is a Canadian online brokerage company. So we are providing trading services for our customers. Customers are mainly based in Canada, and you saw all the movies about Wall Street, right? All the big screens, many monitors, and traders are looking into this crazy stuff, a lot of numbers, a lot of charts. So we built that kind of platform. And our backend is quite big, and we are running a lot of microservices in our backends, both on cloud, on premises, on different environments. And this talk is about our journey, how we approach testing of our microservices, which we are running. So let's get started. And I want to highlight the content of the talk. So we'll have a small introduction. Then we'll try to ask you questions. So why microservices? Why choose microservices as your architecture to go with? Why test microservices at all? That seems to be a good question to ask. And then we'll highlight our ideas behind the framework we created to test microservices. We'll highlight architecture, some features, and I want to list some lessons learned. And for questions, I hope we'll have some time at the end. I have quite a few slides I want to cover. Please, but if you are stuck, raise your hand. Otherwise, we'll take Q&A at the end. So we are pretty much done with the introduction. Let's dive into this question, why at all pick microservices as your architecture? And to answer this question, let's have some jump back in the history. So back in times, all the computation and all the workloads people were having were on the metal. What I meant with that is you are buying the hardware and running on your hardware, your infrastructure, right? Then virtual machines came, and this kind of disrupted the industry, and that also enabled opportunity for cloud vendors or platform as a service vendors to run these microservices now on cloud and provide these virtual machines, on cloud and provide these platforms as a services. Then we saw rise of containers, Docker and the like, and this kind of enabled real microservices development, right? And we know all the benefits of containers compared to virtual machines. They are small, bounded context. You have all your dependencies together and stuff like that. This really accelerated microservices adoption as an architecture. And lately, container orchestrators or platforms like Kubernetes became available widely. Kubernetes is developed by Google. It's open source. There are others as well. Netflix got its own. It's called Spinnaker. There's also Mesos. But Kubernetes is getting quite wide adoption these days. And the relatively recent trend is serverless, which is more or less, again, very connected to microservice architecture, and it's another step in evolution. And again, to ask the question to ourselves why we chose microservices as an architecture, it has a lot of benefits. It can have few downsides as well, but I'm not going to talk about downsides in this talk. So let's highlight few benefits. It enables agility, so you can release faster because your backend and systems are composed of smaller components. You can release them faster. You can test faster. Time to market will be shorter. You can even run 2 or more versions of the same microservice with providing different features and APIs and test on your demographics and users, so it's cool. Next one is scalability. With monolithic architecture, you don't have much choice when you want to scale things. With microservices, Imagine if one part of your system is being used more, you can scale it. And if some parts are used less, you can just keep them. Think about, I don't know, Facebook, like commenting or liking photos. It's used a lot, but there are features like activating your account. I imagine it's not being used a lot, right? So you can scale the parts of your system that are receiving huge traffic, and keep the ones that are not so used so much, shrink down. And high availability and resiliency resilience is very important characteristic of microservice architecture. Again, think about, I don't know, Netflix. And it's a good example when the core business feature or core value of Netflix is streaming of movies, right? But for example, they have also recommendation service. So if recommendation service is down, you can still use the Netflix. It will be usable for you. So it's make system more resilient. And if failures are happening, you can isolate these failures. So one part of system is down, you can architect in a way it will not affect other functioning parts of systems. So cloud native architecture. So all cloud providers are, I'd say, providing very good services to hosting microservices. And if you are on monolithic architecture, you don't have much choice. But with microservices, pretty much everyone is running Kubernetes, like Google's Kubernetes engine, and all the managed services that cloud vendors provide are working very well with microservices architecture. You'll get easy onboarding. Imagine you are getting new hire in the team. If it's a monolithic big application, it's taking some time to learn the environment, the structure, the architecture to contribute. If your architecture is around microservices, it's very easy to onboard. So it's a small bounded context. You can just review the code, you understand the APIs, and you can contribute quite easy. And again, there is a freedom to organize teams around this. So you give your microservices to different teams. Single team owns a few microservices. They are fully responsible for it. You can slice your features vertically. There are good ideas now, good patterns, even microservices at front-end level, micro front-ends. And your teams can own these vertical slices of features from front-end to back-end, so they don't depend on each other, right? There are no more front-end teams and back-end teams. So this is all cool stuff. And let's see why at all test microservices. This is a good question, and I thought this slide will pretty much answer the question, because it all sounds great when you talk about microservices, but this is actually a slide from one of Great Talks Netflix, one of great Netflix presentations. I have a URL there. So this is basically, I imagine this is quite simplified model of what they have in their backend, but if your organization having a lot of users, your backend will look something like this. And if you are not testing this properly, nothing good is going to happen, right? Talking about testing, I have a highlight here. So I just want to mention, traditional testing is not enough. So when you have something like this, only creating a great platform to test, only having great tests, automation, and everything will not be enough to make this thing running. That's why quite great patterns and architectural ideas emerge out of these systems. One is chaos engineering. I think it's again coming from Netflix, which is a different mindset how you run and operate these things, right? Basically, it's the idea is to enhance availability and resilience. So pretty much about chaos engineering, they shut down entire sites or entire parts of their system and see how system behaves, and they learn from that experiment and they make it more stronger and resilient. So writing just great testing framework or great tests will not help. You need to combine DevOps tactics, development, QA, everything together. Google doing it with the idea of SRE, site reliability engineering, to keep these huge systems running. But we'll cover testing part today. And again, the idea of this chaos engineering is that everything will fail eventually. So your memory will fail, your hard drives can fail, your network will fail, and you'll need to design these things keeping these ideas in mind. And this is something, traditionally we were not thinking about this, but the idea is remediation is better than prevention. So when we write and test software, frequently we want to prevent errors, right? Find the bugs before our customers see it, find the failures before customers will see it. But in backend, actually sometimes you can think vice versa. So you can try make system resilient. What it means, you are not trying to make this component not to crash, although you should, but it's very important if microservice is crashing, for example, you can bring it back safely and fast, so entire system is more resilient to failure. And back to testing now. We need powerful tools to test microservices because you saw the slides, right? To fight this complexity, we need to have something equivalent. And when I was putting together these slides, of course, you need to throw Albert Einstein quote, right, into the talk. So this is famous one that says we cannot solve our problems with the same thinking we used when we created them. I thought this is a great one for testing conference, because we are always thinking like when we are writing the code and then we need to test it, we can't apply the same mindset always, right? To find all the corner cases, you'll need to have a different thinking. I think this applies to this quote. But when we started to design this framework, we actually tried to do the opposite. So we thought we need to apply same thinking because microservices need to run on cloud. We thought our testing framework needs to run on cloud. So developers use GCP, Google PubSub, Firestore, all the fancy Amazon Lambdas and managed services. We thought we'll do that as well. So again, to fight the complexity that your system can bring to you, we actually pick the same tools to fight it. And I want to highlight some ideas behind this microservices framework when we started designing it and created it from scratch. One idea we liked a lot is idea of testing as a service, because like something as a service is always sounds cool, right? And why not testing as a service? And in our perception, it was, we were thinking in terms of the teams that will use this platform or people that will use this platform. We want it to be easy for them. So they just write their test cases and that's all. Everything else they will get for free. So automatic runs, reporting, integration, CI/CD. So they just provide their test cases and platform is taking care of the rest. Next idea we wanted to embrace is API centricity, because from the beginning we were thinking if we design this thing and provide powerful APIs, we can integrate this platform to our CI/CD pipeline, for example, and we can build tools on top of this API, whether it's UI tools or command line tools and stuff like that. So we started from APIs actually when we were building this. And again, we wanted to be a cloud-native solution because all our microservices were running on cloud. We wanted our testing framework or platform also run on cloud and benefit from all the services it provides. And the other very important idea was that your testing platform is the product. So we were not looking about to this platform or to this project like it's something in a side like technical thing and customers code or customers product are more important. We actually thought it's equivalent to our products that we deliver to customers and took the same level of care, doing code reviews, following all the development pipeline we have. So this was very important for us. And again, so this is a quote of Brent Trainer. He's founder of Google SRE organization, and SRE stands for Site Reliability Engineering. So Google invented, it's quite interesting ideas behind it. You can research it for yourself. And basically, to run this complex planet scale infrastructure and software they have, they invented quite good ideas. And basically the cornerstone of it is that, so according to Ben, SRE is what you get when you treat operations as if it's a software problem. So this is more about DevOps mindset, right? So they have to run this, they start thinking what software we can create, how we can automate this. So they treat everything as a software problem. And this was a great inspiration for us. And we thought quality assurance is no any different. So you need to apply the same mindset. So we've got a task. We have a lot of microservices. We want to automate them. How we solve this problem. And let's jump to architecture and features of the platform we created. And to do that, let's try to answer what's microservices end of the day. To build the platform, we had to build some simplified model around these complex ideas. You'll have a lot of definitions online what the microservices are, but in a very simple scenario, at least in our perception, microservice is usually providing some API in the left side. So it takes some requests and returns the result. And also, it can cause some side effects. So saving values in database, emitting some events to your event bus or something like that, right? So this is very simplified model of what microservice is. And so what framework must be able to do to test this microservice is basically to send a request to microservice, validate the result, the response from the microservice, and check that side effects. So side effects are quite, it's not very clear. It can be a lot of things. Call to other microservice, some publish a file to Amazon S3 storage, everything like that, right? But side effects are broad, but this is how you try to simplify things, right? To approach them. And from this, we thought this quite simple, just 3 things, right? And then derived an idea of operation. And we said everything can be an operation. So we defined the request as an operation, validation of the response as an operation, and other side effects can be operation. Validate if file is there, validate values from the databases, and stuff like that. After we have defined this notation of operation, we started to think about types of operations we could have. And again, it's HTTP operation is to cover REST APIs, for example, or to make simple HTTP requests, right? GraphQL operation, we had a lot of GraphQL APIs internally as well. And this one is to cover GraphQL operations, to test them. Database operation is to go and check your values in databases, either it's SQL or NoSQL databases. And the most interesting one is GS operation, because we wanted to build the framework with the same technologies we are mostly using. So we had a lot of microservices running in Node.js. We thought let's build the framework with Node.js as well. And importantly, we wanted to QA engineers to be able to jump to business code, business logic, fix some bugs, write some features, and developers jump to framework and create some test cases, right? So it's built on top of Node.js, and we created this idea of JavaScript operation, which is quite powerful thing. So you can build your custom logic into framework. So if these types of operations are not covering it, you can create your own, like if you are going to check some weather or some data from Internet of Things devices or something like that, we don't have APIs for that, you can create your own and enhance the framework. And you can extend this list as you go. Another idea we had after defining this operation idea of operation is that test case is a collection of operations. So we thought when we create this idea of operations, we just put a bunch of operations together. That will be your test case. Imagine like send some REST call, validate the response, then check if database is good, then check if user is inserted there, and do some custom JavaScript code as well. So that becomes your test case. And if we advance on this idea, your test suite is naturally a collection of these test cases, and you can have many test suites for your microservices. And what we did next is we just defined our own JSON semantics on top of this idea of test cases and operations, and created the interpreter for it too. So when you define this thing, you need something that can run it automatically. So we just in a simple sense, so Node.js is an interpreter, or V8 engine is an interpreter for JavaScript. We created our own JSON-based semantics and created an interpreter in Node.js to run these instructions from JSON file. And the very simple test case, so it will not be very abstract for you, just an example. So this is very simple test case. Imagine we have a microservice running somewhere. It's called hello microservice. It got single hello endpoint, and it's provided like REST kind of API. You can do HTTP GET there, and it just says hello world to you. So how we automate that endpoint in our semantics? This is actually the definition of your test case. It says there is a single hello operation. The type is HTTP request. The method is HTTP GET. The path I will call is /hello. And what I expect is I expect microservice to return 200 to me and greet me with hello world. If it returns something else, the result will be different, or status code is different, framework will report the failure. So it's very simplistic test case, but imagine we have very, very complicated test cases just using the notation of operations. I don't want to show that to not scare you. So again, let's iterate what framework needs to be able to what framework needs to have to run these test cases. So if you think about it, it's running an addressable microservice somewhere. So running and deploying microservices on cloud is outside of the scope of the service. We assume your CI/CD pipeline is already running microservice somewhere. Framework is just testing it. Framework needs access to these test cases, and we are keeping these test cases in Git directly, where the microservices codes are. So in every microservice folder, we have /test folder where your test cases are placed. So there is no separation. Code and tests are in the same place. We are having code reviews on every merge request for test case and code. So that worked great for us. And also, framework needs to have access to your service registry. So if you are in an organization that is doing microservices, you usually have some service registry or service discovery. It's basically directory of all your services. If framework has access to that directory, it can show holistic views of your health status of your organization. So every night, frameworks run every test for all the microservices we have, and we are getting this holistic health view of entire backend of microservices. And again, very simplistic model here. What framework needs to test a microservice? On the right side, we have a microservice. Imagine it's running somewhere on GCP, on Kubernetes, and it's got some addressable URL you can reach to this microservice with. And left side is interpreter component from our framework, and it just receives host of the microservices to know when it's running. The Git path of the microservices sources, because we store, you remember, test cases there as well. So framework can just do git clone, and you are getting the test cases for microservices to run. And basically, this interpreter, getting these two parameters, can make the calls to microservice according to the operations we listed in the test case, and then report the result. And result can be very granular. So in this test suite, this test case, and this operation in this test case is failing because you expected 200, and this payload and microservice is returning something different. So it's quite cool. Reports are looking quite cool. And very high-level architecture of the framework. Of course, we picked microservice architecture to build the platform to test microservices. It's running on Kubernetes. We can host it internally with OpenShift, or we can host on Google, for example, Google Kubernetes Engine. And the central part is this interpreter. And we picked ideas of microservices architecture for the framework itself. So imagine you have thousands of running instances of microservices. Then we can scale our interpreter part. So we can run 10 of it. And the reporting part can still stay just single instance. You can have a single pod. So we took advantage of microservice architecture as well. So when interpreters is running tests, it stored the results into data store. We picked MongoDB because so our test results are JSON documents. Mainly, it's very convenient to store in NoSQL database. And then we have, of course, we picked some fancy names, right? Mars, Kronos, Mira. Mira for interpreter is microservices integration, regression, automation, I guess. Not a miracle or something like that. But, inventing fancy names is always cool, right? So the Mars is, I guess, microservices, automation, reporting service, maybe. I already don't remember. So this provides reports from our database, and everything provides well-defined REST, not REST, some of them are GraphQL, but still APIs. And we could build some web application on top of the reporting system it provides, reporting APIs. Of course, it needs to access to Git to get your test cases for microservices. And Kronos is our nightly scheduler. So every night it wakes up and tells interpreter to run some tests. So we are running all the tests from our service directory for all microservices. And if someone commits something into microservice code or test code, we can fire automatic part of CI/CD, run automatic test cases. And I mentioned already service registry. So high-level features that framework is providing, it's automatic runs for the teams that are using this service, nightly or per commit. They are getting reports for free. Teams are getting alerts on failures via email, and they get APIs for integration so they can build their own tools. Someone even mentioned building Chrome plugin on top of APIs, or maybe some plugin for your favorite text editor. You are writing your codes, and you are getting CI/CD support. So these pipelines organizations usually having, when you commit code, it builds your microservice, then it deploys somewhere, and it needs to test. We are providing these APIs from our framework, and CI/CD just calling our API. If it's pass, it can be deployed to other environments. If it's a failure, it's rejecting and getting back to the team with a notification. And of course, we build a web app. We used Vue.js to build it. And we just used the web app to visualize everything that's going on. I want to spend a few minutes on this extended JSON semantics, because it's not very simple, as I showed you in the Hello example. So one powerful idea we used is the configuration and variables for your test cases. Imagine you'll have a lot of things to share between your test cases, and usually when you are writing code as well, you need to define your constants or keep your configuration somewhere. So the idea of referencing you are seeing below, we build these semantics into our JSON interpreter. So whenever you see this $, it will go and search your variables, variables from constants, and you can reference them in a very, I'd say very natural way to special JavaScript developers. And you can see this referencing as well in to reference result of previous operations. It's very powerful. So imagine you have few operations together in a test case. First one is selecting a value from database. You can reference that value in a second operation and chain them together. So we have names for the operations, and the way you address the value from previous operation is with this semantic. So insert new operation is something you already executed previously. And also you can address, kind of bring and put entire chunks of JSON files into your test case. If you have duplicated chunks of data, you just reference them with these semantics. And quite interesting one, as I mentioned, is JavaScript operation. And basically, what it does, you are defining where your JavaScript file is with custom logic and what the function name is. And when interpreter will execute this operation, it will just call the function from exported module from increment.js, pass the arguments, and will say the response needs to be 1. So you can, and then you can use these values as a references in your next operations. So really quick about end result, what we get again. So this is a screenshot from our front-end part of the framework, and this is the list of, it's quite long. I just removed the slider here. This is the list of our microservices, and you instantly see the health status of, of your system. And you can run any test from here as well. And quite interesting and I'd say powerful one, and our engineers who are creating test cases are actually loving this. And if someone used GraphQL before, they have graphical UI to play with APIs. We get the inspiration from there. So we created this screen. This is basically development environment for our test engineers. You just, in the left side, you write your test case. You hit the execute button, and you provide your URL of the microservices that you need to test. You write the run button, and you are getting the interpreter in backend will run this test case for you and return the result in a nice way here. So this is an environment where our engineers are actually creating test cases. And we build this on top of the APIs we provided, I show you before. And here you see, so it's a pass because microservice just returned what we expect. If you have anything else, it will fail naturally. I can show you this part later if you have time. Actually, I have it all running on my laptop. And very quick, we are good on timing, I guess. I can cover lessons learned. This is our last section. And first one, very important one for us was invest in tools for engineer productivity. We created this platform from ground up, and very frequently it enabled us to use it in other places we didn't thought we can use. For example, that CI/CD integration was obvious one, but at the beginning we didn't think we'll do the integration in such an efficient way. So when we build our CI/CD pipeline, we can just call these APIs to test the microservices as they're progressing from one environment to other. The second idea we have just recently maybe, so some organizations that doing business-first APIs, they usually have some idea of API portal. If you visit, I don't know, Facebook APIs or Twitter APIs, there's an idea of API portal. They provide some sophisticated APIs, but services that implementing these APIs can be actually more than one services are implementing single endpoint, right? And this mapping, when you think about it inside of organization, it can be not easy to track. So how you manage your API documentations that they match the actual implementation. Some organizations are separating definition of documentation from implementation for some reason, and it will be hard to track these dependencies. So when we built the platform, we thought about the idea we can take this API documentation, generate automatic test cases based on API description, and execute against actual implementation. And if there are any issues, any discrepancies, we can find it very easy and report it first rather than our customers. It's very important, especially if your APIs are publicly released to your customers and partners. And again, APIs are powerful. This was very, very crucial for us when we built APIs from day one. Then we realized, hey, we can build web app on top of this, or we can build this integration. It was actually cool, and I think this is one of the most important lessons we learned. And another idea, another lesson is treat tests and code as equals. This was very important for us, and first step towards this was storing the test cases with our business code or microservices code at the same place. So everyone is contributing and sending merge requests. It will be reviewed the same way, and we'll keep following our development process the same way as we follow for the business code. So we thought about tests as equal to code. And I think this is last one. 4 fundamental ideas and adhere to them strictly. So when we come up with the idea of operations, or when we come up that we'll build this in a generic way, we'll not build it in an opinionated way, and we'll give idea or ability for others to extend the framework with JavaScript operation, we frequently adhere to this idea, and when during the whiteboard discussion, someone was proposing an idea that is outside of this framework, we try to express everything to bring him back to idea of operation, idea of referencing values. So having these simple ideas from the beginning, built on your architecture from the beginning, is helping you to have this consistent architecture, and I think this was one of the factors. It was a success for us. And when we build this, then we kind of demoed this internally to our teams. Actually, this is the first time I'm talking about the platform outside of our organization. And guys liked it a lot. We did demos, and other teams liked it a lot, and started using it. And we are seeing this widely adopted in our organization. And I don't know if there will be some interest. Maybe later we even had an idea to open source this somewhere, because it's quite generic. There is no any domain specific ideas built inside of it, and it's providing a lot of services out of the box. I think that's it. I'm good on timing, I guess. And thank you so much for coming. I'll take some questions if you have, and if we have some time. Feel free to connect with me and send your questions if you have anything, guys, and we can hang out after this talk as well. And I'll put a small GitHub repo, and I'll put the reference to slides, and later if there will be some materials, I'll put there as well for you. So thank you so much. I think we have a question. Yeah. Thanks a lot. Thank you. I'll get you a mic for you. Okay.
Thanks. So I have 2 questions. First, are there any known frameworks which you used and built on top of it your framework, or you made it from scratch?
Good one. Good one. I was afraid you'll ask this question. So the honest answer is we just built it from scratch, and the good question to ask why, because I think we are not the first ones coming to similar problem, right? I'm sure there are many existing frameworks that could cover some of these scenarios, but we really wanted to take advantage of our infrastructure, and it was a learning initiative for us as well. It was a good challenge, like why not to build it from scratch, to learn some new things. So I'd say we for sure used a lot of NPM modules for Node.js and stuff like that, for GraphQL client, for example, or for APIs, Express.js, and a lot of things. But I'd say it's mainly built from scratch on top of Node.js.
And the second question, I imagine that your main test suite will be quite big. Do you have some mechanism on running tests, parallel running of tests, and how you organize it?
That's a great question. So actually, if you think about microservices, we are getting a lot of test cases, but they are not huge. Because if your microservices are well defined, you have your bounded context and well-defined APIs, it should be small, right? The idea of microservices is small itself. But we have some complex microservices that, with complex business logic, to test it, it requires a lot of test cases, you are right. And when I show you our architecture, we can scale the number of interpreters we are running, right? So we don't have an issue with runtime yet, because other teams are starting creating their services. But by the time we'll scale our interpreter to run all the tests in parallel. That's possible.
Thanks.
Thanks a lot. Okay, guys, if question? Okay. Yeah. Sorry, what was that? API test and
what the optimal ratio of the UI animation test and API animation? It's like this classical
yeah. Yeah. That's a good question. That's a good question. Actually, for now, we are focused more on our backend testing. So this platform is covering UI is kind of outside of it. So this is for the microservices testing. And I'd say we are fully focused on the backend APIs and underlying events, databases, and stuff like that. But it's a good idea. Actually, we are providing APIs that one of our UI frameworks integrated with it. And we are using their interpreter. Imagine our architecture. We are taking their interpreter and putting here. And these guys are getting all the reports, automatic runs, alerts, but we are using their interpreter. But it's kind of not transparent to us what they do in their interpreter, because it's UI testing interpreter on their end. So to answer your question, we are focusing only on backend microservices, no UI testing with this. Yeah, thanks.
First of all, congrats. This looks pretty impressive. Have you tried testing it against other frameworks? Do you have any results and how it looks like?
Again, thanks a lot for the question. This is the most frightening question I could get. So please, please don't ask it. I mean, at this part, so again, we thought about this like we took a blank page and we started coding, right? And I honestly don't want our executive management to hear this, because they may ask the same question. Why you build this from ground up? There may be other frameworks. It was just fun to do it. But I think we had some comparison with, for example, Selenium, which is mainly focused on front-end testing, but you can use it in a similar fashion. I don't know, because we created it, we like ours more. That's the answer, maybe. But we'll do that in the future. We can take notes. Yeah, hope I answered. Yep, question. Thanks.
First, thanks for your talk.
Sure. Thank you.
What was the decision point to start creating this framework? So you just decided from the very first day when the backend was building the microservices, or you faced a lot of issues with traditional testing, and then the services are out from context, and it was going to do something?
Yeah, Thank you. That's a great question too. So I wanted to answer when we started microservice architecture transformation, we thought about testing from day one and created this. In reality, it's not that way. I hope we didn't reach this stage where it is the frightening slide. Oops. A lot of slides we had today. We didn't reach this state when we started creating the framework, but we already created a few microservices that we wanted to migrate on already. But it was like pressing need because we had already we saw we are going to this direction and we wanted to test them. And then we see the need to automate it. Let's switch this off. Time. Okay, thank you so much, guys. We are out of time. Thanks a lot for coming and have a great day. Thanks. Thank you.
Thanks for your speech. It's a symbolic present from our organizers.
Well, thank you so much. Thank you.